Good evening and welcome. Tonight we're going to be going over the astronomy for November. Tonight I've done the lighting a little different. It's a little bit more ambient. Let me know what you think about it. It's mostly for my migraine, but I'm okay, by the way. It's helping, but I think it kind of adds to the whole space theme anyway. I kind of like it. Let me know what you think. So, just like we've done for every month this year, we'll go through the northern hemisphere stars this month and then the southern hemisphere stars. We'll take a closer look at one of the constellations in the sky at this time of year, and then we will learn a little bit more about space. So let's just dive right in, starting with the northern hemisphere stars. It says November is a good month for star hopping. Identify one bright constellation, then, to find others nearby, hop from one star to another. Pegasus, high in the sky, is a good constellation to start from. Let's see, where's Pegasus? Pegasus, right here. Big ol' horse. It says you can draw an imaginary square to connect three of its brightest stars to the star Alpheratz in neighboring Andromeda. Here's right there. Oh, I see 1, 2, 3, and then that star makes it a square. From this square, you can then hop northward to the bright W shape of Cassiopeia, right here. Then hop north again to reach the stars of Cepheus, right here. Let's read about Pegasus. It says, in Greek mythology, the winged horse Pegasus sprang from Medusa's body when Perseus cut off her head. The constellation only shows the front half of the horse. The square of Pegasus is formed by 4 stars: Alpha, also known as Markab from the Arabic word for saddle, Beta, Gamma, and Andromeda star Alpheratz. Then here's Cepheus. Depicting a mythical Greek king, Cepheus is found next to his wife Cassiopeia and close to his daughter Andromeda. Alderamin sounds like a medicine or something. Anyway, Alderamin is the brightest star in Cepheus, but Delta is the most famous. It varies in brightness with a rapid rise and slow fall every 5 days, 9 hours. Other stars that vary in a similar way to Delta Cephei are called Cepheids. There's a little did you know box down here. It says, in 1995, astronomers discovered a planet going around 51 Pegasi, a 5th magnitude star similar to the Sun. The planet's mass is at least half that of Jupiter, and its orbit takes only 4.23 days. Man, imagine if a year was 4.5 days. 1 day for each season. Mu Cephei is a famous red supergiant star. Its color is so striking that the great astronomer Sir William Herschel nicknamed it the Garnet Star because it resembles a red jewel. Alright, let's flip this over very carefully. Here's some good book sounds. There we go. Alright. November in the southern hemisphere. I love that sound. I'm obsessed. Anyway, it says November skies, like those of October, have a watery theme. To locate the stars here, start by facing north and look for the square of Pegasus. This way is north. I see Cassiopeia, Perseus, Andromeda, Pegasus. There's the square. Directly above it, faint stars outline the head of one of the fishes in Pisces. Right here, Pisces. Now follow your line of sight from Pegasus to Pisces, farther on until you find the bright star Deneb Kaitos in Cetus, the sea monster. Cetus, there it is. Keep following through toward the south to spot the stars of Phoenix. Let's read about Pisces. Stars of Pisces are very faint and can be difficult to see. Since ancient times, these stars have represented two fish swimming in different directions, but tied together by their tails. In one Greek myth, they represent Aphrodite and her son Eros, who escape from a monster by disguising themselves as fish. Here's a phoenix. A phoenix, or firebird, is a mythical bird that is reborn from its own burning body. This name was given to these stars in the 17th century. Before then, Arabian astronomers thought the stars represented a boat moored on the banks of the mythical Eridanus River. The nearby bright star Arcnar, right there, marks the river's end. Down here is Cetus. In Greek myth, Perseus used Medusa's head to turn Cetus to stone. Cetus's star Mira was the first variable star to be discovered in 1596. Its brightness varies from magnitude 2 to 10 over an 11-month period, so it usually appears faint. Mira is Latin for wonderful. Alright, let me adjust the book now so we can look at a constellation. Can you guess what it's going to be? Here we go, very carefully. Alright. So, tonight's constellation for this month is Perseus. Let's look at this picture first. So here is a little diagram of what the constellation looks like, or is supposed to look like, So here's the hero, Perseus. There's the head of Medusa. And let me carefully put this down and go like this so you can hear. So here's what it really looks like. Medusa's head. It's really hard to see without the picture. Let's look again. Oop. See this right here in his body. It's Medusa's eye. Very interesting constellation. This is neat. Alright, let's read about Perseus. Here we go. There, I think that does it. Okay. In Greek mythology, Perseus was an invincible hero. The figure that we see in the sky celebrates one of his most famous exploits, slaying the snake-haired Gorgon Medusa, who was so hideous that one glance from her would turn a person into stone. However, Perseus looked at her reflection in his shield, which kept him safe. The constellation is in the northern Milky Way and contains some glittering star clusters, as well as the famous double star Algol, found in the center of Medusa's head. Perseus is best visible during the winter months in the northern hemisphere. Let's start looking at this double cluster, NGC 869 and 884, which is right up here in his sword. It says one of the most beautiful sights in the sky lies in Perseus, the double cluster. This pair of star clusters is visible to the naked eye as a glowing patch of sky on Perseus's border with Cassiopeia, and with binoculars or a small telescope, you can see hundreds of stars. These stars lie a long way from Earth, about 7,200 light years away, and at that distance our sun would be very faint. The two clusters themselves are about 50 light years apart. Here it talks about the Perseid meteors. This cool picture with a meteor zooming by. Every August, meteors from the Perseid showers streak across the sky. Although they are not directly linked with Perseus, they appear to come from that direction. The shower reaches its peak around August 12th, when 50 or so meteors may be seen in an hour, if the sky is very dark. This long exposure photograph shows the trails made by stars circling the pole and the track of a meteor that shot across the sky during the exposure. Let's read about Algol, which is right there Can you see? Right there. Medusa's eyeball. Algol. Traditionally, the star Algol marks an eye in Medusa's head, which Perseus is holding. Its name comes from the Arabic words al-Ghul, meaning the demon. Algol seems to wink regularly, every 2 days, 21 hours. That is, it gets dimmer. This happens because Algol consists of a pair of stars so close together that they cannot be seen individually. The two stars cross one in front of the other as they follow their orbits. The main dip in brightness happens when the dimmer star hides the brighter one for a period of nearly 10 hours. This event is called an eclipse, and double star systems like Algol are called eclipsing binaries. So here we can see what it looks like when Algol's at a magnitude 2.1. There's Algol, and there's a faint star directly behind it. And when Algol dims to magnitude 3.4, it looks like this. You can really see the difference there. And it's when Algol is behind the faint star. Let's read about Mirfak, which is this bright star, Perseus. So it says, the brightest star in Perseus is Mirfak, which lies at the heart of a cluster of stars. Though the cluster lacks a popular name, it is as beautiful as many better-known clusters. To find Mirfak, look for the S-shaped pattern that is sometimes referred to as the roller coaster. The S-shaped pattern. I'm guessing that's this. I'm not sure. Anyway, let's read about John Goodrich. That's as best as I can do with my little desk, okay. Algol's notorious wink was first explained by an English amateur astronomer, John Goodrich, who was deaf and dumb. He lived in the 18th century when disabled people were considered to be unintelligent. However, Goodrich received a good education, enabling him to read lips and speak, so I guess he wasn't dumb after a while. He studied the stars from his window and measured Algol's brightness changes. When Goodrich was only 18 years old, he correctly explained the cause of these changes. Way to go, John. Alright, let me slide this back and turn this delicious sounding page. Turn this page. Alright. So tonight's, or at least this month's, space topic is small solar system worlds. Put this down very carefully. Okay. Our solar system contains far more than just the sun and planets. There are millions of other smaller objects, such as asteroids, comets, and dust that orbit the sun. Although they are all different shapes and sizes, there are many links between them, and sometimes it can be hard to tell in which group a particular object belongs. They are all leftovers from the formation of the solar system, the material that did not form into planets. The bodies that formed closer to the sun are mainly rocky, while those that formed farther out are mostly ice. So starting with Pluto, this book is about 10 years old, so there were no images of Pluto at that time. That's the best we had. Let's read about it. Pluto is a small icy world, only 1,420 miles across, with a moon half its size named Charon. Discovered in 1930, Pluto is regarded as the most distant major planet in the solar system, but it is also the largest known body in the Kuiper Belt. On its elongated orbit, tilted by 17 degrees to Earth's orbit, it is sometimes nearer to the Sun than Neptune. No spacecraft has yet visited Pluto, which isn't true now. And this map was built up from brightness changes observed when Charon passed in front of it. Cool. In many ways, Pluto and Charon resemble the larger moons of the giant planets. Let's read about the Kuiper Belt real quick. Beyond the orbit of Neptune lies a part of the solar system known as the Kuiper Belt, after Dutch-American astronomer Gerard Kuiper. In 1951, Kuiper suggested that this area was probably a source of comets. Up to 1 billion icy bodies inhabit this zone, but only a few hundred have been observed so far. There's much more now. The image below shows a distant galaxy right here. To the left of it, a Kuiper Belt object, or KBO, is seen hurtling toward the galaxy. In the second image, the KBO is shown ringed with the galaxy. The time span between these images is just 4.6 hours. That's so cool. Can you see it? Right there. How that dot is not in this picture. It's over here. And now it's right there. Very interesting. Alright. Let's read about the asteroid belt. Here we go. Between the orbits of Mars and Jupiter, there are thousands of small rocky bodies known as asteroids. Asteroid Ida. Asteroids are objects that never manage to form a single rocky planet. Some, known as near-Earth objects, stray closer to Earth than Mars and may occasionally cross Earth's orbit, posing a possible collision threat. And this is about meteorites and impacts. In addition to the large asteroids, there are also millions of smaller fragments in space. Occasionally, these rocks fall to Earth and are known as meteorites. A typical meteorite may be the size of a football. Very rarely, a house-sized object may fall to Earth, forming a crater, such as this one in Arizona. That's pretty terrifying. Let's learn about meteor showers. I love a good meteor shower. Occasionally, Earth's orbit passes through dense swarms of comet particles. Dust grains from the tails of passing comets collide with gas molecules in Earth's upper atmosphere and vaporize, heating the air around it. This can result in a shower of, or maybe 100 meteors an hour. These showers appear as blazing streaks of light across the night sky. There's a list here of annual meteor showers. We have the Quadrantids near Boötes. Peak dates are, here we go, lights on it. Here we go, let's try that again. The Quadrantids near Boötes. Peak dates are January 3rd through 4th. Hopefully you can see. The Eta Aquarids are near Aquarius. Peak dates are May 4th through 6th. The Perseids near Perseus. Peak dates is August 12th. The Orionids near Orion. Peak dates are October 20th to 22nd. And the Geminids near Gemini. Peak dates are December 13th through 14th. I feel like I always wind up seeing this one. I don't know, I guess I'm looking at the sky more often because it's darker, and I always see meteors in December. Even though, like, the Perseids are, like, the more famous ones. Let's read about comets and their tails. The heart of a comet is a chunk of ice and dust only a few miles across. As this nucleus nears the sun, ice evaporates, creating a huge cloud called a coma, and long tails of gas and dust up to millions of miles long. Bright comets such as Hale-Bopp in 1997 are a rare sight. They can appear unexpectedly and take just a few weeks to cross the inner solar system. My analytics say that a lot of my viewers are like in the 30, 40, 50s range, which, hello. That's okay, I fall in that range too, it's fine. So a lot of you, I'm sure, remember Hale-Bopp. So in the comments, leave any cool stories you might have about seeing Hale-Bopp. I remember seeing it and being very disappointed. It didn't look as exciting, but I didn't have any telescopes to really get to look at it. I can only see it with the naked eye. The path of a comet. The paths comets follow around the sun are stretched ellipses or ovals. They are grouped into into two main types: long period orbits and short period ones. The orbits of short period comets stretch no farther from the Sun than the Kuiper Belt. Halley's Comet, which comes around every 76 years, is an example. Long period comets take thousands of years to travel around the Sun. Their orbits extend out to a region a light year or more from the Sun. This region is thought to be home to trillions of comets and is known as the Oort cloud. Let's see this path. Incoming comet from the Oort cloud may be at any angle to the ecliptic. Here you can see the tail starting to form as it gets closer to the Sun, and then as it moves away from the Sun, the tail disappears, flies off. Let's look at this box up here and read about Carolyn Shoemaker. Put this down. Comets are named after their discoverers, and American astronomer Carolyn Shoemaker has more comets to her name than anyone else alive. In addition to 32 comets, she has also discovered more than 300 asteroids. Together with her husband Eugene and David Levy, she found a broken-up comet orbiting Jupiter in 1993. In 1994, the comet fragments crashed into the planet. This is like a time-lapse photo. I'm not sure what I'm looking at here, but it does look really cool. It is a comet. So that is it for tonight and for this month. Let's have some book sounds before we go. Thank you so much for watching. I hope you found this video relaxing and educational. And I hope that you have a very good night.